Hello, it's Dr. Mears, and today we are going to be doing SAT Strategy Session 1. And you're going to have to work with me here because I'm going to try to teach you some strategies and I'll show you how to do the math behind the problem. I might have some flipping back and forth because I did make an answer key just to make this go a little bit quicker. So we'll see how it works out. All right, number 1. Erin bought a pair of shoes for 40% off the original price. She paid $54. What was the original price of the shoes? So we are looking for how much they were originally before we got the 40% off. And the math behind the problem, SAT Strategy Session 1, first what we have to understand is increase by a percentage and decrease by a percentage. So the final amount equals the original amount times 1 plus that percentage divided by 100. Let me break this down for you. The reason why we divide the percent by 100 is because we need to get it into decimal form. Unless you have on your calculator or whatever calculator you're using, if you have a percent sign. And then we add 1 to it because we are increasing. And we multiply by the original amount to get to that final. So here, same thing. I just sneezed, excuse me. We need to get this into decimal. This is decrease, so we are subtracting. And we multiply by the original to get to the final. Do you have to remember this? No. Am I reviewing it because some people like to know a formula or like to know where I'm getting all of the numbers from? Yes. So again, you do not have to remember this, but it may spark a little bit of remembering how to do increase by a percentage or decrease by a percentage if this is how you learned it. So let's use this. So we have our final amount, which was $54. And I'm just going to put a paper over everything. There we go. We have a final amount, which was $54. We want to know the original. We know that it was decreased by 40%. Okay, what does that next line look like? So we have the final amount. I just changed the original to X. X is our unknown, so I don't know what that original is rather than writing out the word. 1 minus 40 divided by 100 is 0.4. Now, some of you learned that if you do 40% and you move the decimal over 2 places, that gets it out of the percent and into a decimal. You can do that. That's just a strategy, but the decimal moves over because you're taking it out of 100. That's what a percent is. It's percent out of 100. So that's why we divide it to get it out of that percent because it's out of 100. And so the strategy of moving over, absolutely fine. Okay, our next step is 54 equals X, and this is times 0.60. And we are going to have to divide both sides by 0.60. And so we're solving here. So our original, which is our X, so I could have written, and I'm actually just going to write X here because I like that. X, and I'm going to write original underneath. Original price is going to be $90. 54 divided by 0.6 is $90. Now, let's say you did not remember increase, decrease percentage. Absolutely fine. There is another strategy to do this. What we could have done is we could have used the answers to find 60% of the original. So this 60%, that's just from here. And so I just divided 60 by 100 to get it out of the decimal, 0.60. And I'm going to multiply it. Now, you're going to see me use these little dots. Dots are multiplication, but I'm actually going to be changing these to parentheses. So 84 times 0.6. Let's see what that is. So these were our original answers. Let me go back here. So our original answers were 84, 90, 94, and 135. So I'm using these answers, and I'm going to multiply it by 0.6. So let's see, 84 times 0.6 is 50.4. Now we don't want 50, we want 54. So this is, remember, that's what we paid for it. Okay, 90 times 0.6, and that's multiplication is 54. Oh, that's it. Check. So we don't need these two. We don't even need to check those two. We know the answer is going to be B. So there's other multiple ways of doing this problem. The ways that I present to you here today aren't the only ones. It's just how I'm thinking about it as a mathematician in my mind and some of the strategies that I use. So if you used another strategy, absolutely fine, and share it with others. If these strategies don't work, talk with others and share what you know. Okay, let's go to number 2. Number 2. Of 80 people who took a test, 656 passed. At that rate, how many people would pass if 280 people took the test? So mathematically, and this is the total, okay, mathematically, I would go to setting up people who took the test and people who didn't take the test, and if more took the test. So we know that 56 passed, and there were 80 that took it. And that was in the problem. All I did was I pulled it out. 80 people took it, 56 passed. I know if there are more people, if we went from 80 to 280, I want to know how many are going to pass. So here is what it looks like. Now, if more, oops, I'm so sorry. If more took the test, I know I have 280. So I had 80, now I'm at 280. We don't know how many are going to pass. So I would go and do a proportions on this. If you start to see two things that we can compare in a problem, I automatically write that data down. Again, this is just how it works in my mathematical brain. And then now that we have a nice proportion, yes, you can cross multiply. So we're going to get 80x equals, so 80 times x, 80x equals 56 times 280 gives you 15,680, 15,680. We are going to divide both sides by 80. And we get x, when we divide this out, as 196 passed. And so let's go see if that's one of our answers. I'm going to leave that here. For number 2, yes, D, 196. And we did that by setting up a nice proportion. Okay. And if you need to pause any of this, please feel free to pause if I'm going too fast. So hopefully these are helping. Okay, number 3. The price of a certain type of coffee increased from $5.99 per pound to $7.29 a pound. That's some expensive coffee, went to $729. What percent increase? Now, reading these problems, I would try to do at least 2 read-throughs and underlining key words and terms, just like I did. So the price of certain coffee has increased. We know it goes up from $5.99 to $7.29 per pound. We need a percent increase. And you know what I'm going to do? I am going to show you the percent increase formula right now because that is the math behind it. And if you notice, there's no multiple choice here. So this is an open-ended problem. So you are going to have to fill in the boxes. Okay, so let's see what we have here. Percent increase, decrease. Here's our formula. Percent increase, decrease equals the new price minus the old price, and I put that in parentheses to keep it together, divided by the old price. And because we want percent, we now need to multiply it by 100 to get it into percent. When we were dividing, we took it out of percent. Now we need it into a percent, so that's why we multiply. So new minus old divided by old. So let's see what that looks like. Oh, one more note. If the answer comes out to be positive, then it increased. If it's negative, then it decreased. So we'll just have to look at what the answer. If it's positive, it's increased. Negative, it's decreased. Okay. So let's put our percent increase in. We got new price, $7.29. Old, $5.99. We're subtracting them. Divided by $5.99. That's old. We want to multiply that by 100 because we want to get it into a percent. Let's see what that looks like here. I first subtracted because I kept that together with my parentheses. So 1.3 divided by 5.99, still times 100. I get 0.217 when I divide those. I want to get it into a percent. It's now a decimal, so turn it into a percent times 100. I get 21.7%. And that's the answer. So using my percent increase, and it's positive, so we know if it's positive that it did in fact increase. It actually increased by 21.7%. That is a lot. Okay, let's go on to number 4. Just flip my paper over here and make sure my paper clip's not in the way. All right, number 4. The population of species increased by 27.3% between 2008 and 2010. The population increased 38.5% between 2010 and 2012. By what percentage did the population increase from 2008 to 2012? Round your answer to the nearest tenth of a percent. There is a lot in this problem. So let's just unpack it a little bit. Let's read it again. So this is a second read. Let's read it one more time just to see what we got. All right, so the population of species increased 27.3% between these 2 years. So over the 2 years, it went up 27. Then the population increased again between another 2 years, 2010 and 2012. We want to know what percentage did it increase from the start, 2008, all the way to 2012. Round the answer to the nearest tenth of a percent. Now, because they said round the answer to the nearest tenth of a percent, my first instinct was just to add these. But because they said round the answer to the nearest tenth, I don't think it's going to be as easy as just adding these two answers together. So I am going to tell you right now, from doing this problem before, and I'm going to show you how to do it, it's not as easy as doing that, especially because they said round the answer to the nearest tenth. So automatically, I'm going to take out 65.8. And this is where I'm doing the strategy first, everybody. So if it's not 65.8, we know it increased twice. That's a lot. We have one increase here and one increase here. So looking at these, if it increased twice, it is going to be a higher percentage because it's doing it double time almost. So I'm thinking it can't be these two because it went up by 38.5%. So I'm not very sure it's going to be A or B. I'm thinking it's going to be D. So just by knowing that they're actually telling me I'm going to have to do some work by saying you got to have to round, that we're not going to be doing this, I just took an educated guess that I'm thinking it's going to be D. Now, if you're pressed for time on the SAT and you want to use this strategy, that's okay because you have 44 problems and you have 70 minutes. So you do have to pick and choose those problems that if you're like, ooh, I'm going to try this strategy, or you might want to circle and come back from this one because there's so much in this problem. Okay, but now let's get to the actual math behind what we're doing here. So I'll show you. All right, for number 4. All right, so we're looking at years 2008 to 2010. And what I did is because we're increasing by percentages, I started with how many people were there in 2008? We don't know. They just told us what percent increase. All we know is that from 2008 to 2010, we went up 27.3%. And then 2010 to 2012, we went up 38.5%. but we don't know how many people we started with. The easiest number to start with when we need a start amount, especially when it's a start amount of people, is going to be 100, because that's what percents are out of. So when working with percents, the easiest number is to use 100. So I'm going to say, hey, in 2008, we had 100 people. You can do that. It's okay to use a number and work with that number so that it's going to help you find a percent increase from 2008 all the way to 2012. Okay, so I'm going to choose 100. So let's start over here. So 2008 to 2012. I'm starting with 100 people. If I increase that by 27.3%, I'm going to get 127.3. That's what I mean by it's simple, because all you have to do is add 127.3 to get 127.3. Now I need to do another increase. So now I need to increase it by 38.5%. And so I'm going to use my percent increase that we did back in the other problem, where we take that original amount, our 127.3, we multiply it by 1 plus, I'm going to change my percent, so I'm going to divide it by 100. And you can even just put this whole thing in a calculator just like this if you wanted. And what I'm going to get is 176.3. So 176.3. So that's how many people there are now. And so now I'm going to have to find out what this total percent is. Okay. Again, you can do this a couple different ways. And I did put a little side note here. So this was percent increase and decrease here from the last problem. This is just what I used here. Okay. Now, if you saw, wait, 176.3, and I'm not going to show you this, 176.3. Wait a minute. We could just do 176.3 minus 100, just like we added 27.3 here, and that gives us 76.3. And guess what? You got it. That's D. And what our hunch was in the beginning when we just used a little strategy was right. So the answer is D. Now, the math behind it, if we do percent increase, which was the last problem that I showed you percent increase, we took the new minus old and divided it by old and multiplied it, times it by 100, we do get 76.3%. But because we're working with such a nice number like 100, we could just simply subtract it and we get the same exact answer. So a lot of work, as you can see, that went into doing the problem. We did use a strategy in the beginning, which did allow us to take an educated guess. So sometimes that might be the best way to go, especially if you're pressed for time. Okay, let's go on to number 5. Number 5. The ratio of female birds to male birds in a habitat is 2.4 to 1. If there are 123 female birds in the habitat, approximately 40% of the birds are male raptors. Approximately how many male birds are raptors? Again, this is a lot to unpack, so you might have to read through it a couple times or even 3 times and underline some words. So we have ratio of female birds, female to male, is 2.4 to 1. We know there's 123 female birds, and 40 of those are male. We want to know approximately how many male birds are raptors. All right. Male birds are, 40% of male birds are raptors. See, I missed that. So let's read it one more time. 40% of the male birds are raptors. How many male birds are raptors? They want to know an amount. I need an amount. Okay, strategy time. I would go through and try multiplication. Definitely, we're going to be using these numbers. You use all of the numbers. You can use one, but any number times one or any number divided by one is itself. So you know the key numbers are 24, 123, and 40. So again, if you are pressed for time, see what you can do and try to multiply and divide how you're going to rationalize how you're going to use the ratios, total number of birds, and percentages all together, because it is a lot to unpack. I'm going to show you the math behind it. Okay. So first, what I did. Number 5. First, what I did, remember, we're comparing two things, females and males, and they gave us the ratio. So when we compare two things, I automatically start writing my numbers down in a table. So we have female and male, we have the ratio 2.4 to 1. We know the number of birds is 123 for females, but we're not sure about the males. They give us more info. And this was my fourth. I think I read this about 4 or 5 times. And I just start writing things down. Here's your more info. 40% are male raptors. And what they want to know, our key question, are how many are male raptors. We know 40% of them are. So we have a couple things to figure out. So what's the first thing that we're going to figure out is first find the number of male raptors. And I have that set up here. I have that already set up. So 2.4 divided by 2.4 divided by 123 equals 1 over our unknown, we don't know, x. And so I'm going to go through and solve that. Cross multiplication, and then I'm going to divide both sides by 2.4. And I come out with 51.25 males. Now, here's the thing. I know we're working with decimals. I know we're like, hey, we're talking about birds. Don't round yet. Remember they said round to the nearest tenth. So at our final answer, let's round. Let's not round yet. So up here, we know 51.25 are males. All right, excellent. What's our next thing to find out? How many are raptors? Okay. So second, find the number of male raptors. So what we have to figure out is what is 40% of 51.25? So that's what's next. And again, you could do this a couple different ways. So what is 40%? We could change that. We could take that out of percent. So 40 divided by 100 times 51.25. So you just multiply it. So what does that look like? So it would be 0.4 times 51.25, so 20.5. So male raptors is 21. Now I have an or. I do have an or. So I just set up the equation here. Male raptors are 21. Or a lot of people like setting up proportions, so we could set up a proportion. You still have to know the total males, so we still had to find that first. But if you don't like doing the what is 40% of a number, if you don't like that, if you like proportions, here you go. X is the unknown number of male raptors. We know total males. We know 40 out of 100 are male raptors, so we're using that. Very similar to what we've done before. Cross multiply, we get 20.5. Number of male raptors is 21. And we see back here that our answer right here would be 21. Again, you may want to try to work the numbers as best as possible, but if you don't know how to start this problem from the get-go, definitely try some multiplication division. However, if you start setting up a table and you start using proportions, this is the way to go where you set up male and female. Okay. Number 6. A truck with a sales price of $9,000 is expected to depreciate by 10% each year. What will the value of the truck be after 3 years? All right, let's read it again. A truck with a sale price of $9,000 is expected to depreciate by 10%. So we're going to be decreasing by 10% each year. What will the value be after 3 years? Okay, so we know it goes down 10% each year. All right, well, definitely I need to find out what's going to go down by the first year. Notice, not multiple choice, open-ended. Okay, let's start. All right, so decrease by percentage. Here we go, number 6. Now, because we're depreciating, which means decreasing, here's my decrease by percentage, amount times 1 minus the percent over 100. Again, you do not have to remember this. Some it may, you could do this a couple different ways, and I actually give you 2 different ways of doing this. So year 1 value, 9,000 times, taking out decimal, 0.9. So if you want to just jump, if you know that this is going to be 0.9 because 1 minus 0.10 is 0.9, you can jump there. Absolutely fine. Okay, so year 1, let's see how much it's worth. Ooh, $8,100. Okay. Now what we're going to have to do is we're going to have to take that 8,100 and find year 2. So we're doing the same thing where we're multiplying it by 0.9 because we're going down, and we're going to get 7,290. Oh, okay. Let's see year 3. Year 3 value. Here we go. Oh, 6,561. This really happens, everybody, with cars. Once you take them off the lot, they're going to go down in value. So year 3's value is $6,561. Now, you could do this another way, or knowing I just wrote down the decrease by a percentage, here's your amount, 1 minus the percent over 100, to the number of years. So how many years do we have? We have 3. So you could raise it to that third power. Again, you don't have to remember all of this. Okay? And there's no guess and check with the answer key, so you don't have to remember. You could just remember, I know I'm multiplying by 0.9 every time and do it 3 times. Absolutely. But because we're doing it 3 times, 1, 2, 3, this is just getting repeated 3 times. So 0.9 is getting repeated 3 times. So 0.9 to the third times 9,000 is the same exact answer. Either way, this is the math and the why behind what we do. All right. Next. Let me flip my sheet here. Number 7. And I believe this goes to 10, so we're almost there. If you need to pause, of course, and take a break, this is for you. So bear with me. All right, number 7, the results of an exit poll for an election indicated that 240 people voted for candidate X and 190 people voted for candidate Y. If 48% of the 12,424 registered voters are expected to vote, how many can be expected for candidate Y? So let's read through it again. The results of an exit poll for election indicate that 240 voted for X and 190 for Y. So we're comparing 2 things. This is definitely reminding me of proportion because we're comparing 2 things. We know 48% of the total are expected to vote, and they're expected to vote for Y. We need to know the amount, how many voters voted for Y. Feels very similar to the other problems that we've been doing. So let's unpack it. So definitely a reading question. And you saw that I started to compare exit poll and expected votes. So the first thing is how many people are expected to vote. So what is 48% of the 12,424? So again, we could use what is, so we just take the 48 and turn it into a decimal, multiply it, and we get 5,963.5. So the total expected voters are 5,964. Or we can set up a proportion. So, and you saw me compare exit poll versus expected. So we don't know how many people are to vote for candidate Y out of 12,424. I was actually are expected to vote. 48 out of 100, very similar. And so we're going to come with 5963.5. All right. Now we need to find how many can be expected to vote given the exit poll. So what does that look like? So we have 190 candidate Y over the total, 190 plus 240. We have Y over the total, 5964. So Y equals 2,635.26. So that's what can be expected from how many we know turn up to vote. So this is how many voters we expect to have. That's what we had to find first. Total expected voters, and we used that and our exit poll results to find how many are going to vote. Expected to vote for candidate Y. Okay, moving on. All right. A store increases the price of a sweater by 20% and then reduces the price, the increase by price by 20%. What percent of the original price is the new price? Okay, so let's see what we did. First, we increased it by 20%, and then we decreased it by 20%. So we decreased the increased price. What percent of the original is the new price? Let's see, and notice there's no answers here, so we can't take any answer shortcut. Okay. So what are we looking at? Again, read the reading question. So what percent of the, whoops, I'm so sorry. What percent of the original price is the new price? Unknown. We don't know what the original price is. This reminds me of the other one with the years, 2008 and 2012. So we have no idea. Okay. So what number am I going to pick? Right, we're working with percents. Let's pick 100. So let's say that the original was $100. Okay. What did we do? So let's say the original is 100. I chose 100 because 100 is easy to work with. I increased it by 20%. What did I get to? You're right, 120. And then I decreased it by 20%. And I got to 96. So how did I get that? My new divided by my original equals percent over 100. So from 100 to 96 is 96%. And if you needed to do the 120, we're decreasing it by 20% to get to 96, you can. It's up to you. Okay, so that was where we had to pick a number in order to get to that next one. All right, let's see. 9. One more after this. Yeah. The sales tax in state A is 7.5% and the sales tax in state B is 4.75%. Which of the following statements is true about the purchase of a car with list price $21,500? All right, so let's see. Sales tax in state A is 7.5%. Sales tax in state B is 4.75%. Okay, so state A is definitely has a higher percentage. All right, we have a list price of $21,500. We have a lot of choices. Before I even read the choices, I'm just going to see how much taxes. How much are we going to pay on $21,500? So let's see that first. So we have state, oops, I keep doing that to you, sorry. State A, 21,000, and this is times. I have to take the percent out of 100. We have to change that to a decimal. Again, if you wanted to move it over 1, 2, you are moving it once, you're moving it twice, and remember you have to put your 0 in because now you have a placeholder there. So it would be 0.075. which is the same thing as dividing it by 100. We have to multiply that. So our tax for state A is $1,612.50. Okay, let's see state, or again, I think you're starting to see a theme here with these proportions. X over 21,500, 7.5 over 100, cross, multiply, and divide, and I get the same exact thing. So one or the other, either one works. Again, this is just a strategy session for whichever one you want to choose. All right, B, state B, again, whichever one, if you want to multiply it by, this would be 0.0475, that's fine. Multiplication here, multiplying these two. Or you can set up the proportion. We're going to get the same answer. But what do you notice? State A is definitely higher. They had a higher tax. And now we ask ourselves, let's see how much of a difference there is. So I just subtracted state A minus state B. And when I subtract, I get $591.25. And so now it becomes a reading question. I know that state A is more than state B. So here you would have to read through. You would save less by purchasing in state B than less than 500. Let's see, am I saving less than 500 here? No. Okay. You would save between 500 and 1,000 by purchasing the car in state B instead of state A. That's a possibility because this is in between 500 and 1,000. You would say between 1,000 and 15. Nope. You would say between, nope. Okay, so automatically $591.25 does fall between 5,000 and 1,000. 500, sorry, and 1,000. Getting tongue-tied here. All of the words. Okay. And let's do the last one. Number 10. On its own page. Told you there was going to be a little flipping around. All right, thank you for bearing with me. Last one for session 1. In 2015, the population of city X and Y were equal. From 2010 to 2015, the population of city X increased by 20% and the population of city Y decreased by 10. Ooh. If the population of city X was 120,000 in 2010, what was the population of city Y in 2010? Okay, so let's see. In 2015, they were equal. Okay, from 2010 to 2015, city X increased, city Y decreased. So one went up and one went down. In 2010, city X was 120,000. We need to find city Y in 2010. Guess what? Yes, we're comparing two things. There's a lot of data here. And so because we're comparing two things, let's write out what we have. And you could do a little guessing and checking and doing an educated guess with how much, but because we're almost at a 40-minute video, let's go through and see how the math has been done. Okay. So we have city X and city Y, 210 to 210. I'm getting tired too. 2010 to 2015, same thing. Let's see what data we have. We know city X in 2010, we added 20%. We know here we lost 10% for city Y, but we have a starting point. And we know they're the same here, right? We know they're equal. So this amount and this amount are going to be equal. What do we set up first? So let's find city X population in 2015. Oh, let's go do that. Oh, okay. So we know we're going to take the amount. So we know that it started. That's our start amount times 1 plus, there's our general formula. And so when we do that, we get 120 times 1.20, and we get the population of 144,000. So we know this is 144,000 and we know this is 144,000. So now that we have an amount here, and we're actually now going this way. So when we go backwards, we're not decreasing by 10% anymore, right? We're going to be increasing. So this amount was more here. So we know that. So we know it's going to be higher than 144. So what are we going to do? We know citywide decreases by 10% from 2010 to 2015. This means if we go from 2015 to 2010, it increased. So let's find that increase with our percent increase, which is 160,000, which was one of our answers here. 160,000 was C. Now I do have an or, so let's look at the or. Flip it, continued. We can use each answer to see which had a decrease of 10%. Oh, that's a little easier. So we're going to need to use 0.90. That's from here. We took the 10%, we took it out of a percent by dividing it, 1 minus, because decrease, and we have 0.9. So we needed this number still. We needed how many there were in 2015 because this was the equal number in 2015, so we still need this. So we could go through and see using our calculator which one. We just multiply. So 60,000 times 0.9, that gives us 54. That doesn't work. 90,000 times 0.9, that gives us 81. Nope, we don't want that. Remember, we're looking for this number here. 160 times 0.9. There we go. That's the magic number. So instead of setting up a whole nother percent increase, decrease, you could have just used those answers and seen which one equals 0.9. All right, so this has been 10 problems, session 1. We saw a lot of proportions being set up. We reviewed percent, increase, decreased, and we reviewed increasing by percent and decreasing by percent. Hopefully it helped you to remember a few of the things that you've learned about those, and I hope this video helped. Thank you.